Hello friends, this video on equilibrium part 4 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 3. So what is the chemical equilibrium? Chemical equilibrium by definition is nothing but a state in which both reactants and products are present. But they don't react. They don't change, the concentration don't change with time. For example, I'll tell you. Let's suppose you take some A and B as the reactant. It should give C and D. Correct? So let's suppose you took some 10 moles of A and 10 moles of B at T is equal to 0. Correct? So now let me write it here. So you have A and B which gives C and D. You took 10 moles of A, 10 moles of B at T is equal to 0. So you expect that after some time T is equal to infinity, A and B will react and it should give 10 moles of C and 10 moles of D. That is the expected behavior, but that doesn't happen. So what we have seen is, so we have started with, in this we are taking only A or B, because if you take both A and B, you have to draw two lines. So let's suppose we took A here and we took C here. So the concentration of A decreased over a period of time, that is fine. But it didn't become 0. It stopped after some time. Similarly, the concentration of C here, because I took C here, increased, right? Maybe at equilibrium, what chemist found was this was 2, this was 2, this was 8, this was 8. Maybe, just figure, maybe 3 or 7, not sure. So the question is why these molecules didn't react to form this. This is why, because we have the reaction going in the backward direction also. And please note, this chemical equilibrium occurs only at the reversible reactions only, because once I have reached this position now, 2 and 8, I'm assuming that this is the place where I'm getting this equilibrium, 2 and 8. So after this, the backward reaction is also happening. The backward reaction is also happening. C and D is combining to form A and B. Similarly, A and B is also combining to form C and D, and both the reaction at the same rate, and that's what we call equilibrium. So we had A and B, some 10 moles each. We reacted those A and B. We expected all the moles of A and B will be consumed to give me C and D, but we found that the reaction incomplete. We have A and B 2 moles each, but the reaction is not going forward. It stopped. So the chemist did all the research and found that in this case what happened is, and this happened only for some of the reversible reactions. For example, you have, let's say, hydrochloric acid and you put in water, it will break into H plus and H minus ion. It will break completely. It will break completely. There won't be any equilibrium here because there is no reversible reaction. We'll talk about those things later. Just understand that this happens only for the reversible reactions, and we'll talk more about these later. So at this stage, at the equilibrium stage, the forward reaction and the backward reaction both are happening at the same rate, same time, and that's why it's at this stage. Correct. So as I told, equilibrium happens only for the reversible reactions. Let's take some of the reversible reaction. You can note this down. They're very good reactions. For example, you have rusting of iron. You have H2 plus I2 gives Hi, N2O4 breaks into NO2. You have N2 plus 3H2 gives ammonia. This is also a reversible reaction. You have PCl5, phosphorus pentachloride. It breaks into PCl3 and Cl2. You have NH4Cl. It breaks into NH4Cl minus. You have N2 plus O2 gives NO2NO. You have this reaction CS3CONa. It becomes CS3CO minus and N plus. You have CS3COH, a very weak acid. It becomes H plus and CS3CO minus. NaCl also gives a reversible reaction, NaCl minus ions, and AgCl also gives a reversible reaction. Some of the reversible reaction, we have tons of reversible reaction chemistries. So to start with, you can know only few of them. So as I told, equilibrium exists. I have, let's suppose I had A plus B. It was the equilibrium with C and D, and I had started with 0, 0, 10 moles of A and B, and I ended up getting 2 and 2 and 8, let's suppose, of this. The question is why I didn't react completely. And I told that the forward reaction, the backward reaction both took place and it kind of balanced. So to understand this, what you can do is you can take two beaker of water, one water, one without water. Take almost 30% of this. You have this water pipe. Put the pipe, close the lid, close this end with the hand, and take this pipe and put it here. You'll find some water here now. Again, put the same pipe here and take this pipe to this one. So if you see in this case, let's suppose first movement, let's suppose if this was, let's suppose 50 ml. And I'm assuming that this guy, what it does is, it takes 10% of whatever available in the system, right? So I had 50 ml, I started 50 ml and this went here, 10% of 50 ml is 45. So 10% of 50 ml is 5. So I got 5 ml here, right? Now, so I have now here, instead of 50, I have 45 ml. Correct. Now from this, I'll take water and put it here. So from this 10% is how much? I'll just put this pipe again here like this. I'm sorry, it is not clear. So 10% is 0.5. So in this run, 0.5 will go. Right. So this will become 4.5 ml and this will become 45.5 ml. Correct. This will become 45.5 ml. Now from again you will do. So again 45.5, 10% is again 0.545 ml, or again you can say that yeah, it will be 4.5 ml, right? So 4.5 ml will go here. So this will become 0.5, 4.5 plus again 4.5, and this will become minus 4.5. That will become 41 ml, and this will become 9 ml. In the next iteration, again you will take from here. So from 9 ml you will take 10%. This is almost 1 ml. So 1 ml will go here. So this becomes 9 minus 1, which is 8 ml. And this one will become plus 1. This will be 42 ml. So now I have 42 ml here and 8 ml here. Now from this I again take, so this is beaker 1, this is beaker 2. From beaker 1 again I take to beaker 2. So 10% of 42 is almost 4 ml. So 4 ml will go here. And here I will have minus 4 ml. So here I will have 38 and here I have 12 ml now. Now again from beaker 2 to 1 I will take. So again I will take 10%, almost 1 ml. I'm just assuming it. So this will become 11, this will become 39. Again you keep doing it. Again you take 10% of this, that will become 4 ml. Again will go from here. So this will become 35, this will become 15. So you keep doing it, you will see that it was 0 here, it became 15 now. It became 35 here. You keep doing it, you see that it will become 25 and 25. Right? It will become equilibrium. Now even if you keep doing it, right, even if you keep shuffling water from here to here 10%, you see that this will always be same. Because when it's 25, when you are moving 10%, it will go here. In the next item it will come back. So it will always be in equilibrium. And that is the logical thing here. If you see, it's dynamic here, you know, you're moving water from beaker 1 to 2 to 1, you keep doing it, and you see that if you keep doing it, you'll see that it will reach a stage where it will become 25. I don't want to do a lot of calculations again, but if you keep doing this from 35, it is 15 now, and if you do from here, it will become minus 1 again, here it will become plus 1, it will become 36, it will become 14, in the next iteration again 4 will go, this will become 32, this will become 16, so the values will keep changing, and end of the day you'll see it will become 25. And that's what the equilibrium is all about, right? Both the reaction happens starting from the first. It's not that when I'm reacting A plus B is equal to C plus D, only when this stage is reached, that reaction started, the reverse reaction. No. In the very first instance itself, the reverse reaction also was there. Whenever, let's suppose T is equal to 0, it was my 10 and 0. The backward reaction was not possible because C and D was not there. T is equal to, let's suppose at 1 minute, it was, let's suppose 9 and 1. At that time itself, the reverse reaction also started. T is equal to 2 minutes, let's suppose it become 8 to 2. At that time also reverse reaction was there. T is equal to 3, it become, let's suppose 7 3. At that time also reverse reaction was there. It's not happening only in one direction. In both cases, in all the scenarios, reverse reactions are also happening. Right? And at the end of the day, it will reach a stage where it will reach equilibrium. Even if you keep shuffling here things, the reaction reaches the same, it will reach equilibrium. Right? That's the logical explanation of the chemical equilibrium. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.